Alright, so let's start with the first one. The first one says the distance between 2 points. That's easy, right? So if you have 2 points, here is my marker. If you have 2 points here and here, right? And in coordinate geometry, it's all about distance, angle between points and their coordinates, right? So if they say this point is given as x1, y1, and this point is given as x2, y2, how can you get the distance from here to here? You use this formula. X2 minus, we've done it before with me, Abi. Alright, so that's by the way. Please, for those of you that are watching, this is the formula for distance. So the distance we're looking for is from here to here. This is the distance. We'll do an example later for all of them. Number 2, it says the midpoint. So if you have those 2 points, you want to know the middle, right? So you have here and you have here. You want to know the middle point. This middle point, you use this formula. x1 plus x2 over 2 and y1 plus y2 over 2. It will give you the middle. That's the middle of the 2 points. Any 2 points that is given. There are some questions like that where we need to get the middle of 2 points. We'll use this. Okay. The next one says the point which divides 2 points in the ratio P and Q. Now, if you have 2 points here and here, right? They have a distance between them. Then also, this one is what? x1, y1. Okay, that's that's not P. And this one is what? x2, y2. These are the coordinates of these 2 points, right? Now, this one tells us the middle. Okay, that's we are dividing that distance into 50-50, right? But this one now is not telling you the middle again. It's telling you you want to divide it into ratio of your choice. Do you understand? You're not dividing it into 50-50 again. Maybe you want to divide it into ratio, maybe 1:5, something like that, right? Or you want to divide this line into anything you like, Sha. If you want to divide, maybe this one will be 2:3, okay, or 4:1, or 5:7. Anyhow you want to divide it into a particular ratio. Now the ratio you want to divide it is now your P ratio Q of your choice. Okay, this one is half of this one, which is 50-50. This is the formula you use. But if they tell you a particular ratio, so this is the formula they are going to use. This will now represent the x coordinate, which is also like combining this one and yes, just like combining this one and the P and Q. Okay, see, here was x1 plus x2 over 2. Here is the x1 plus x2, but now you are introducing the ratios P and Q down. Same thing with this one. It's supposed to be y1 plus y2 over like that. Okay, if you notice, P is attached to x2, P is also attached to what? Y2. So that you don't go and put P as x2 here and put P as y1 here, you'll be wrong. Okay, if you are using P for 2, P and P will stay with P and P. Q for 1, Q will stay for 1 here, Q will also stay for 1 here. Don't get the what's it called? You don't get it wrong. Okay, so that's for that. We're going to do an example on that as well. Now, number 4, the gradient. Okay, gradient is slope. Okay, so different lines, this line and this line and this line, they are not the same. They have different gradients. This is positive gradient, this is negative gradient. Abi, so gradient is just how is y changing with x. Okay, that is why the formula is change in y over change in x. Okay, so the different slope or the different angles that the different lines are aligned will form different gradients. Okay, so we have some gradients that are 1, we have them that is half, we have them that is minus, just different gradients. Okay, we'll show you the direction that that line is facing. Okay, so that's that. So this is easy. Now this one, very important. Condition for 2 lines to be parallel. So if we have 2 lines that are parallel, we have something like this, right? So if they are parallel like this, that means they are moving in the same direction. Is that not so? That means their slope is the same. Okay, that's why I say that the slope of the first one is equal to the slope of the second one. Are you seeing it? So if they are parallel, or if they are parallel, the slope of the first one also was slope of the second one. For instance, they might ask you for probably the equation of a second line that is parallel to a first line, and they will give you the first line slope and expect you to know that since the both of them are parallel, you are supposed to use the slope of the first one for the second one. They expect you to know that. Okay, while if they are not parallel, if they are perpendicular looks like this. If they are at angle 90 to each other, okay, so this is perpendicular lines, right? So they don't have the same slope. Okay, the relationship between the two lines, if this is line 1 and line 2, based on their slope, is given by this. So what I normally do is I inverse the slope and then put negative. For instance, if you give me the first slope as 1/2, right? I turn 1/2 upside down. What does that give me? 2/1, abi? So the second slope will now be, turn it upside down and put negative, minus 2/1. Okay? So if the first line is maybe 2/3, the second perpendicular line to that line will now be what? Minus 3/2. I use instead of wasting my time. Okay? If you have something like maybe 3/4, what would this one be? Minus 4/3. What if you have minus 5/2? What will not be here? 2/5. Beautiful. Okay, so this is the relationship between slopes of negative and positive. Okay, so this is the first 5. Okay, if you've written it down, we'll do some some classwork on it, any classwork on it. Okay, if you know these ones, there's no question on coordinate geometry that you will not be able to answer. Let's go to the next one. All right, so this second one, now we have acute angle between two lines, right? What am I talking about? If you have a line like this, a particular slope, whatever slope it is, I don't know, and let's call this one M1, that's the slope of the first one, or the gradient of the first one. Slope and gradient are the same, right? And you have another line, okay, M2, thank you, M2, right? Both of them are two lines with different slopes, right? And there's an acute angle between them. What's an acute angle? Yes, that's why I make the angle small. It's less than 90. Are you seeing? And they're asking you calculate the acute angle between these two lines, right? So what do? You use this formula. Tan theta equals to what's it called? One of the angles minus the other angle divided by what? 1 plus you multiply the two angles. Okay, for instance, if this angle now has a slope of, let's say, 2/3, and this one has a slope of, let's say, 1. Okay, so I can easily do 1 minus 2/3. It will give me 1/3. Abi, I will now divide it by 1 plus and multiply this to 2/3, which is what? 2/3. Is that not so? So to get the tan theta of these two slopes, this will now be what? 1/3, right? 1 plus 2/3 is what? 5/3. See how this is looking at me. It's 5/3. It is over what? 5/3. If you divide this by this, your answer will give you 1/5. So that means tan theta of those two angles is 1/5. You now get the tan inverse, get your answer, get your angle. It should give you an acute angle. Okay, if not, that thing you are doing is rubbish. Your tan. That means that if you are using calculator, that means that they will give you special angle. What do I mean by special angle? 0, 30, 60, 45, and 90. It will not pass those 5 angles. Okay, maybe later I'll do a video on how to get from just looking at it to know the angle that it's talking about. But mind you, tan theta is what? Sin theta over cos theta. So with that relationship, you can get any special angle. But that's by the way, sha. Number 7, equation of a straight line. Now, from number 7 to number 10, we are talking about equation of a straight line. Okay? Because it's very important. How do you get equation of a straight line? This first one now, this is the general equation of a straight line. Y equals to mx plus c. Right? Y equals to mx plus c. What is y? Of course, in your coordinate geometry, you have your y-axis and your what? X-axis. And also, so your y-axis and your x-axis should be present in your equation. That is why you are seeing y and x here to show the relationship between y and x. M here is the what? Slope or gradient of that line. Just like I said, it will tell you, it will give you an idea of the direction of the line and the change in y as the y is changing with the x. Okay, that's what slope does, right? Then this c is what? The y-axis intercept. So if you have a graph like this, y and x-axis, right? And your slope goes like this. Let me put it like this, right? What is your c? You can see that, oh my, this is my line. You can see that from this graph I did now, my straight line touches the x-axis and also touches the y-axis. Is that not so? So in this case, your c is your what? Is your intercept on the y-axis. Okay? So if it touches here at 2 and touches here at -1, for this particular case, your y is what? 2. Okay? Because that is where this line touches the y-axis. Okay? So you don't use the x-axis in this case. Okay? But when your equation of a line now looks like this, x equals to m y plus c. Now the c here is the x-axis intercept. Why? Because here in this equation, x is the subject of formula, while in this equation, y is subject of formula. All these things I'm saying, we are going to give examples and classes so that you understand them better. Okay? But I'm just telling you how to use these equations. For instance, if I give you a line now and I tell you that the line has a y-axis intercept of plus or -3. It touches the y-axis at -3. That's down. And it has a slope of 1. Right? What is the equation of that line? You just tell me y equals to, use this one. 1 times x is what? X plus -3. That's -3. This is your what? Equation of your line. Y equals to x minus 3. That's it. Okay? So if I change this to, maybe I change this to maybe 4 and I change this to half. What is the equation of a line now? It becomes y equals to what? Half x plus 4. Is that okay? So that is if you are giving your what? Y-axis intercept and your slope. What if you are not giving the both of them? What if you are not giving the both of them? What if you are giving, like in this number 8 now? What if you are giving the slope and that your line is passing through a point? They didn't give you the intercept. Okay? Like, this is it. Now, they didn't give you what this place is, right? But they told you that it is passing through a particular point. Let's call that point x1, y1. Okay? And we have our slope, m. Right? How do you still get the equation of that line? You use this formula. In this formula, there's no mention of c, right? There's no mention of c. But you can see that there is x1, y1 in that equation. And there's also m. What if you're not giving m, you're not giving c, but you are giving 2 points. That is, it passed through this point and you also pass through another point, x2, y2, right? There's no m in this case. Okay? So depending on the question will determine which equation you will use to get your equation of the line, right? So in this case, what do? You replace your m in this equation with y2 minus y1 over x2 minus. So it's basically the same thing. The only thing is that we have 2 points now, and here we had our m. Okay? So just replace m with the equation of m that I gave you initially, and you get your new line. Okay? Then finally, what if you are not giving any points, you're not giving anything, but you are giving the x and y intercept? Like in this case now, let me clean this and this. You are not giving anything, but you are giving this place that the line touches the y-axis. Here I called it B. Okay? So you are giving B and you are giving what? A. How do you get the equation of this line? So that means that if you are giving, yeah, but I'm doing video for the rest. When they come, Hey, I thought they bought lights. All right, so that means that if you are giving the two equations, the two intercepts, right? A and B, right? You can still get the equation of the line. Just do x over intercept on the x-axis plus y over intercept of the y-axis equals to 1. By the time you expand and rearrange, you still get your answer. Okay? Any question? For this one, equation of a line which perpendicular distance from the origin makes an angle with the positive axis. So they're asking for equation of a line, but the condition they gave us here is that there is a distance. So it's something like this, right? So there is an acute angle. There is x, from here to here is x, from here to here is y, and then from here to here is p. So if you have something like this, and they're asking for equation of this line, just use this. What is x? What is y? Because the angle between them, the angle between them will give you your p. If you put this relationship, you get your answer. That's for number 11. We're going to do something on it. For number 12, I said if you have this as equation of the line, maybe ax plus by plus c, where a, b, c are constants in this particular question. If they ask you to get the x-intercept, right? Because what is the x-intercept? X-intercept is at this point, Abi. You can see at this point, what is your value for y? 0. And at this point, x is what? 0. So for the x-intercept, your y will be 0. So just put y to be 0 and you solve for x. If you are looking for y-intercept, you put x to be what? 0 and you solve for y. That's how you get the intercept using this equation. Now, the interesting one now is this number 13 and 14. If you are asked to get the area of a triangle, see our face, area of a triangle, right? A triangle looks like this, right? And here they gave you the coordinate of this point, coordinate of this point, coordinate of this point. That is what is known as vertices, right? So if here is x1, y1, if here is x2, y2, and here is x3, y3. That's what I mean by this, okay? So if they give you the vertices of the 3 points on the triangle, how do you get the area? That's this area of the triangle. Just use this formula. Now look at how I used to remember this particular formula. You can see here we have x1, x2, x3. Are you not seeing it? So it looks like the x's are what? Adding themselves. But for you to get the y, after 1 is what? 2 and 3. After 2 is what? 3 and 1. After 3 is what? 1 and 2. That's why you can know the formula. Okay? So first and foremost, you just do what? Half. Remember that the formula for triangle normally is half base times height. Okay, so it's just like this particular thing that is inside here, like the base times height. Okay, so half is important. I think even for the area of quadrilateral, I also put that half as well. Okay, so half is important. Then just do your what? X1, X2, X3, right? And then you come here, you put your, after 1 you have 2 and 3, after 2 you have 3 and 1, after 3 you have 1 and 2. So follow that, what's it called, sequence. Okay, for area of the quadrilateral, it also has its own sequence. Okay, so the quadrilateral looks like, what's the quadrilateral? 4 sides, right? So you are giving the vertices coordinate. What is this? Abi? And this one is what? And this one is what? And this one is what? So you are giving the 4 coordinates of whatever quadrilateral, whether it's rectangle, square, whatever quadrilateral they're giving. Right? It could be trapezium, it could be anything. How do you get the area of that quadrilateral? Now look at this one. This one is half is xy that's multiplying xy. Xy multiplying xy. Xy multiplying xy like that. Okay? But what is the sequence I'm going to follow in this one? You start with 1, 2. After 1, 2, 2, 3. After 2, 3, 3, 4. After 3, 4, 4, 1. Are you seeing it? So that's the sequence. While you know what you minus, it's just the same thing, but you are exchanging it. So if you do 1, 2 here, you do 2, 1 here. If you do 2, 3 here, you do 3, 2 here. If you do 3, 4 here, you do what? 4, 3. If you do 4, 1 here, you do what? 1, 4. So that's the sequence for quadrilateral, okay? So you just know that x is not like triangle that x is on its own. This one is xy, y1, xy, y1, like that. Okay? Then the last point here is how do you get the point of intersection? Point of intersection, okay? What do I mean by point of intersection? Exactly. Okay, so that one is easy. You have one line here, the both of them cross themselves, right? If this equation of the line is y equals to mx1 plus c, let me put everything 1, 1, 1, okay? And this one is y2 equals to m2x2 plus c2. So they have different equation of lines, okay? How do you get this point? How do you get this point? Let's call it x3, y3. How do you get this point? You can get this point by if you solve these two equations simultaneously, your answer for x and y will give you. Okay, so that means in essence, x and y they are the same thing. Okay, nothing like y2. They are the same thing because they meet at the same point. Okay, so that's that. Time for